This is the first ever Common Core Geometry Regents exam. These are the answers to it. I'm going to get prepared to go over all of them with you. Let's do this. Which object is formed when right triangle RST shown below is rotated around leg RS? Well, for these three-dimensional rotations, your answer is almost always going to be a cone or a cylinder. If you want to do it by hand, you reflect it in 2 dimensions. You connect it with curves. What shape is that? Cone. Again, because you're always connecting it with curves, it's going to almost always be a cone or a cylinder. The vertices of triangle JKL have coordinates whatever. Under which transformation is the image not congruent? The only type of transformation that does not produce a congruent image is the only one that's not a rigid motion, which is a dilation. I don't care what the dilation is, a dilation does not produce a congruent figure. Translations, rotations, reflections are all rigid motions. A rigid motion preserves distance and creates a congruent figure. Number 3. There's no graph paper on this particular question, but like anything, if you can put it on a graph, put it on a graph. The center of circle Q has coordinates 3, -2. That's my center. If circle Q passes through R, which is 7, 1, 2, 4, 6, 7, 1, what is the length of its diameter? Well, this is the center, and this is a point on the circle. This is the radius. To find that length, I do distance. If you don't know your distance formula, good luck to you. See you next year. Change in X, 1, 2, 3, 4. Change in Y, 1, 2, 3. That's 16 plus 9. That's rad 25. That's 5. The radius is 5. If the radius is 5, diameter is 2 times the radius. The diameter is 2 times 5, which is 10. Somewhere if the D and the D get confusing, this is distance. This is diameter. Use a graph. It makes everything a lot easier. This is just identifying the transformations. Which sequence of transformations maps figure 1 into figure 2 and figure 2 into figure 3? Well, from 1 to 2, let's check the orientation. This is ABC. This is ABC. The orientation is the same. It's a translation. Then from figure 2 to figure 3, let's check the orientation. ABC. ABC. It has the same orientation. It's a reflection. It's a translation followed by a rotation. That's just identifying your transformations, and always check for orientation. If the orientation has changed, then it's going to be a line reflection. And to do that, I'm just picking a letter. I'm going in a specific direction. This is ABC. This is ABC. This is ABC. I'm going clockwise in all the cases. All the orientations are the same. If you still don't get that, ask me or ask somebody. You need to recognize this. A right triangle with an angle involved. This is Sohcahtoa, which is great because if you prepare yourself for this exam, you know how to do Sohcahtoa. Make sure you put an X on what you're trying to find, the height of the tree, label your, and what else? Point is 20 feet from the base of the tree. Here's the point, here's the base of the tree, here's your 20. Label your A, your O, and your H. H, the angle connects the H to the A, which makes this the O. What's involved? O is involved, A is involved, toa. Tan theta equals opposite over adjacent. Tan 34 equals X over 20. Tan of 34, put that into your calculator. Ran 4 decimal places. I got 0.6 6, 7, 4, 5 equals x over 20. Cross multiply and solve. X equals to the nearest tenth, 13.5. There are two types of Sohcahtoa problems. This cross multiplication is inverse. When you're finding the angle, it's inverse. When you're finding the side, it's cross multiplication. I'm sure we'll see another one later. Cross sections. You need to know your cross sections and your key understandings. You have the list of all the cross sections. We did the activity with it. The sphere only has a cross section of a circle. All shapes, their bases are always a cross section. Circle is the base of a cone. That's it. All right. Know all your different cross sections. A shipping container is in the shape of a right rectangular prism with a length of 12, a width of 8, and a height of 4. That first sentence is giving me some information. It's not telling me to do anything. We could draw it. To draw a rectangular prism, draw a rectangle inside of it, connect them. It says the length is 12, width is 8.5. Perfect. The container is completely filled with contents that weigh on average 0.25 pounds per cubic foot. Weight. Weight equals weight times volume. Volume equals area of the base times the height. Length times width, pi r squared. In this particular example, because it's a rectangular base, it's length times width. So B is LWH. B is 12, 8.5, 4. B is 408 feet cubed. Now that I have the volume, I go back to this formula. W equals WV. The weight of 1 cubic foot is 0.25. The volume is 408. You can put that into the calculator. I got 102 pounds. 2 steps for the weight problems. First, find the volume. Multiply the volume by the weight. Just one of these. Very important question. You got to look at your inscribed and your right angles, which is not always true. CG and FG. I don't see any particular reason why those would be congruent. So I'm going to move on to the next one. Let's erase it so we can more clearly see. I'm looking at choice 2 now. CEG, FEG. They're both inscribed to the same arc. Therefore, they're congruent. Let's take a look at CE over. Let's skip down a little bit to this right here. Are the triangles similar? Well, yes, the triangles are similar because those angles are the same. They're vertical angles. These angles are both inscribed to this arc. So once I have 2 angles, I'm good. And I also know, again, that these are congruent because they're both inscribed to that arc. So I know the triangles are similar. So if the triangles are similar, are those sides in proportion? Well, I have CE over EG, CE over EG. That's on my left-hand triangle, okay. FD over DG, do those correspond? Yes. CF and GF, I'm sorry, CG and FG, not going to happen. There's no particular reason why that and that has to be. So write the equation of a line. The standard form for the equation of a line is y equals mx plus b, where m is slope and b is y-intercept. So I don't know what the slope is, but I know it's perpendicular to this line. So I have to first get y by itself. The slope of this line is 2. I know that perpendicular lines, I had negative reciprocal slopes. So the slope of my line must be negative 1/2. Now that I have the slope of my line, to find b, I sub into y equals mx plus b. Y, oh, no, I don't need to do that. It just asked which one was perpendicular. So I know it's got to have a slope of negative 1/2, which leaves has a slope of negative 1/2, choice 1. I don't care about the b. I care about the slope. For polygon rotational symmetry, you need to know it's 360 over n. So, choice 1, an octagon, is 360 divided by 8, which is 45. Choice 2, a decagon has 10 sides, so that's 36. Choice 3, a hexagon has 6 sides, so that's 60. And choice 4, a pentagon has 5 sides, so that's 72. Which one has a minimum rotation of 45? Choice 1. That's a minimum rotation. Any multiple of 45 will have as well. So an octagon will have 45, 90, 135, 180, etc. A decagon will have 36, 72, 108, etc. Any multiple of those values will give you rotational symmetry. We'll map it onto itself. Candy corn. We have a song for this. Candy corn, bases separate. Let's see, what's it asking for? It's asking for AC. Are the bases involved? No. If there are no bases, put the top over top. Side over side. Do I have the side? Kinda. I know that this whole side is what I'm trying to find. This whole side is 14. So 9 over 9.2, 14 over x. That's it. Cross multiply and solve. 9x equals 14 times 9.2 is 128.8. Divide by 9. X equals, to the nearest 10th, 14.3. This question you should just straight up have memorized. Cosine of one of the acute angles is equal to sine of the other one. If there's a C, the right angle, that one can't be involved at all. Cosine of one acute angle is equal to the sine of the other. That type of question you should straight up have memorized. Which information is not sufficient to prove that ABCD is a parallelogram? There's 5 ways to prove a parallelogram. There's 5 pictures. Opposite sides congruent. Opposite sides parallel. Diagonals bisect each other. One pair of opposite sides, both congruent and parallel. Opposite angles congruent. You need to know those 5 pictures. Those are the 5 different ways to prove that triangles that, to prove that something's a parallelogram. So it says a quadrilateral A, B, C, D has diagonals AC and BD. Which information is not sufficient to prove that it's a parallelogram? Well, AC and BD bisect each other. If AC and BD bisect each other, that checks out. That makes it a parallelogram. That gives me this picture right here. AB is congruent to CD. BC is congruent to AD. That gives me this picture right here. AB is congruent to CD. AB is parallel to CD. That gives me this picture right here. Choice 4 isn't going to work. I don't really have any colors left. Oh, I got blue. AB is congruent to CD. Looking at the blue now. BC is parallel to AD. That is not one of my pictures. If the side that's parallel is the side that's congruent, it's a parallelogram, but you can't have one pair of opposite sides congruent and the other parallel. That's it. Moving on. I'm going fast. I like this. Of course, as I said that, did it freeze? Yeah, it kind of froze on me. So let's see what happens here. I'm going to take a little break. Let's pause it. And we're back. The equation of the circle, blah, blah, blah. You need to know how to put this into center radius form. This is completing the square. I'm going to have to do it twice. There's only one x value, so I'm not going to have to do it for x squared in this case, actually. I'm only going to have to do it for the y's. Y squared plus 6y plus something equals 7 plus something. To determine what goes inside, it's b over 2 squared, which is 6 over 2 squared, which is 9. Next step in completing the square is the factor. It's going to always be the same factor written twice. Rewrite it as a binomial squared. Now that I have that, to get my center, I negate what's in the parentheses. So the plus 3 becomes negative 3. If there is no parentheses, the coordinate is 0. My radius is the square root of the right-hand side, which is 4. 0, negative 3. Radius 4. Done. 15. Which statement is true? Well, I'm going to jump right to number 3, and I'm going to see if these triangles are similar. Because if they're similar, I'm going to have to use a similar triangle properties. AB is 9, BC is 15, DE is 6, EF is 10, B is congruent to E. There's 3 ways to show that triangles are similar. There's AA, there's SAS, and SSS. Now this isn't the proving triangles. This S means they're in proportion. So I see SAS if they're in proportion. Are they in proportion? Let's find out. 15 over 9 would have to be equal to 10 over 6. 90 equals 90. Yes, they're in proportion. This is SAS. They are similar. So if they're similar, let's take a look and see what else is going on here. It wants to know if angle CAB is congruent to angle DEF. Well, do these angles correspond to each other? Doesn't look like it to me. And I can also look at these letters here. A and E are in different positions. They're not corresponding. That's not the answer. That's not true. AB over CB, so let's do that in red. AB over CB, that's little over big, equals FE over DE. That's big over little. No, that's not consistent. That's not true. Choice 4, let's go black on that one. AB over DE. Here's AB. Here's DE. All right, those correspond so far, little over little. FE over CB. No. If this one goes first, then this one would have to go first. This one goes first. This one goes first. Not consistent. Not true. Choice 3 is the only one that's true. You gotta be able to get these similar triangle questions right. They ask them all the time. The triangle ABC is dilated by a scale factor of 3. You can draw 2 triangles if you want. ABC, A prime, B prime, C prime. Which statement is true of the image? Is 3 times A prime, B prime equal to AB? Is 3 times the bigger one equal to the smaller one? No. Is B prime, C prime equal to 3 times this? Yeah. Is angle A prime 3 times this angle? No. When you dilate something, they're the same. So that can't be true, and that can't be true. With similar triangles, when you dilate them, the angles are always the same. They're in a ratio of 1 to 1. Choice 2 is the only one that's correct. We want to prove that these are parallel. Well, to prove these are parallel, I need to show that alternate interior or alternate exterior or corresponding angles are congruent. Being everything inside, I got to find alternate interior angles. So basically what this problem wants me to do is find alternate interior angles. CFG is congruent to FCB. Are those alternate interior angles? Looks like it to me. Let's check the rest. ABF, BFC. Are these alternate interior angles? Nope. EFB, CFB, CFB, nope, not alternate interior angles. And CBF, CBF, and GFC, GFC, nope. This would be alternate interior with this one, but not that one. To prove lines are parallel, you have to show that either alternate interior, alternate exterior, and corresponding angles are congruent. Scale factor. That's easy if you know what to do. Scale factor equals image over original. EC. Let's do with the images. It says CD is the image. It says that right there. It says this is the original. Is EC the image? Yes. Is EA the original? Yes. That one looks good. Let's check the rest. BA. Is BA the image? Nope. EA. Is EA the image? No. EA. Is EA the image? No. Choice one. Scale factor is the image over the original. A gallon of paint will cover approximately 450 square feet. Okay, nothing to do yet, but I know that a gallon of paint is going to cover square feet. Square feet is area, so I'm going to probably do something with area. An artist wants to paint all the outside surfaces of a cube measuring 12 feet on each side. I got a cube. I'm painting the outside. The outside of a three-dimensional shape is surface area. I have a song for this, don't I? SA equals 2LW plus 2HW plus 2LH equals the surface area. Now, it's a cube, so they're all 12. So it's going to be 2, 12, 12, plus 2, 12, 12, plus 2, 12, 12. For a cube, it's going to always be the same. I could make this one a little bit easier, but if it's a regular rectangular prism, you know, you have to know it's that. So that is 2 times 12. I'm just using my calculator a little bit right now, and I'm getting 864 feet squared. What's the least number of gallons of paint he must buy to paint the cube? Well, he needs to paint 864 square feet. 1 gallon of paint covers 450 square feet. So 864 divided by 450 is 1.92. 1's not enough. He has to buy 2. We're moving through this thing pretty nicely. This is similar to we had a question similar to this earlier on with circles about inscribed and right angles. We also had those similar triangles question. I asked a lot of theoretical angles questions. You gotta be prepared for it. I don't really see anything too important here. Diameter AC is perpendicular to CD at point C. I know that because it's a tangent and a diameter, so I know those have to be perpendicular. So let's see, choice 1, ACB. ACB is an inscribed angle. It's congruent to BCD. BCD is your special case inscribed angle. They're not inscribed to the same arc. One's inscribed to that, one's inscribed to that, so I don't see any reason why those would have to be congruent. I'm not going to cross it off, but, you know, I don't see anything there. So this is probably not going to be true. So I guess I will work it out. ABC, ACD. ABC is an inscribed angle to a diameter. So it's a right angle. ACD is a tangent meeting a diameter, so that's a right angle. Since they're both right angles, yes, they must be congruent. BAC. BAC is an inscribed angle to arc BC. DCB is your special case inscribed to arc BC. They both intercept the same arc, so they're congruent. And I'm frozen again. So let's pause you. And we're back. Another similar triangles question. Tons of similar triangles and circles, angles, and theory. You just gotta know how to do these. AC is 12. BC is 7. DE is 5. The perimeter of triangle ABC is 30. What's the perimeter of triangle DEC? It says they're similar. Similar triangles, the sides are in proportion as are their perimeters. So I can put the perimeter of the big one over the perimeter of the small one. And now which sides correspond here? The 12 and the 7 correspond. Why? AC is the first and third. DC is the first and third. Also, you can tell by looking at it. So I'm going to put, because I put the 30 on top, I have to put the 12 on top over 7. Cross multiply and solve. 210 equals 12x. Divide by 12. X equals, I'm getting my calculator for this one. 210 divided by 12 is 17.5. Moving on. Line dilations. The song for this, BKB, MC slope. That's if it's centered at the origin. If it's not centered at the origin, then the line just stays the same. So, I know that, it's not telling me too much here. It just wants to know which one could be its image. Well, the slope has to be the same. Okay, it's not asking you to find the equation after it's dilated, which it often does. It just basically wants to know which one has the same slope. A couple different ways to do this. I'm going to do it the most procedural way. I'm going to solve the original one for y. And I get y equals negative 2/3 x plus 8/3. So the slope is negative 2/3. So which of these has a slope of negative 2/3? I believe it's choice 1. Because if I get y by itself, that's a little sloppy. Break it down a little bit lower here. I got y equals negative 2/3 x plus 5/3. Slope's the same. When you dilate something, your result is parallel, which means it has the same slope. I'm just going to show you another way I could have, instead of getting y by itself for everything, I could have just lined it up. So you see how for all these I had the x's, then the y's, then the numbers. So I could have taken my 3y equals negative 2x plus 8, lined it up. I would have had to bring the 2x over, write the 2x first, plus 3y equals 8, and these signs are the same as these signs. Either way. A circle with a radius of 5 was divided into 24 congruent sectors. Somebody's got way too much time in their hands. The sectors were then rearranged as shown in the diagram below. So nearest integer, what's the value of x? Well, basically what we have here is we took the circumference of the circle, and each of this side and this side, each makes up half of the circumference of the circle. So I need to find half the circumference of the circle, which is half the circumference is going to be half by 8. So what's the circumference of the circle? It says that a radius of 5, which means that the diameter is 10. It wants the answer to the nearest integer, so you're going to type pi in, and I got 15.7. The nearest integer is choice 2. It's a tricky question the way it's worded, but it has to do with circumference. You're seeing the outside pieces of the circle. That's what circumference is, because the top and bottom together make the full circumference. We have to cut the circumference in half to find that distance. Which statement is sufficient evidence that triangle DEF is congruent, not similar, congruent? AB equals DE, and BC equals EF. So AB equals DE, BC equals EF. No, I need to prove 3 things to show that triangles are congruent. 2 things not going to cut it. Choice 2, angle D is congruent to angle A. Angle B is congruent to angle E. Angle C is congruent to angle F. There's 3 things, but that's S and don't work. So that's not it. There's a sequence of rigid motions. That's one way to prove triangles are congruent. That maps AB onto DE. Yeah, those correspond. BC onto EF. Those correspond. AC onto DF. That looks pretty good. I got side, side, side. I think that's going to work. Let's try, let's see, lost a little accent here. Let's try 4, because maybe that one works too. I don't know. I got to be careful. I got to check out everything. There's a sequence of regional motions that maps point A onto point D, AB onto DE, angle B onto angle E. No, all I got is a side and angle. Point doesn't count. I'm not going to cut it. Again, a point is not a side or an angle. So the answer is choice 2. Yay, open response. I don't know how to use a compass on this thing, on the smart board here. I always do it, on the chalkboard, so I'm going to be doing what I tell her not to do and do it freehand. To construct an inscribed square, start by drawing in, with a straight edge, a diameter. Then you construct a perpendicular bisector of the diameter. So you open the compass more than halfway. If I'm putting a needle point here, I swing my arc. Then I put the needle point here, and I swing my arc. And then I connect them. This is obviously very freehand, a very rough sketch, and I draw that in. Now I have 1, 2, 3, 4 points on the circle. I connect them. That's my square. This, again, is a very freehand. If you do on the exam what I just did, you're getting nothing. You're getting laughed at. You're getting humiliated. I'm going to show all the other math teachers your disgusting construction. You must use the compass, and you must use the straight edge. Okay, but that's the procedure for an inscribed square. Make sure you know all your constructions. Common Core telling you what the answer is. Explain why angle NLO is 40. Well, it says it's a parallelogram. It says the N is 118, says the L and O is that. I'm going to assume it doesn't tell me. I want to find angle NLO. Keep in mind it says explain, so I'm going to have to use words. Well, if this is a parallelogram, if M is 118, O is 118. Angle O is 118 degrees because opposite angles of a parallelogram are congruent. Now, I've got angles of a triangle. So, I have 118 plus 22 plus x equals 180. 140 plus x equals 180 minus 140 minus 140. X is 40. So angle NLO is 40 because, well, the angles of a triangle add to equal 180. Do I have to explain it in words? Yes, that's what explain means. Not bad. Not bad at all. Sweet. Love these questions. The coordinates of AB are A, negative 2, 4, 6, negative 2, 4, 5. B, 4, 0. Make sure you label with letters what's what. Point P is on AB. Fantastic. Determine the coordinates of point P such that AP to PB is 2 to 3. Partitions. Delta X and delta Y over P. What's delta X? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's delta Y? 1, 2, 3, 4, 5. How many partitions are there? Well, if being cut a ratio of 2 to 3, there's 5 partitions. So it's 2 and 1. Now for the answer to the question, I now have to count. 2, 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. 1, 2, 1. Direction counts. If it's AB, A is where you're starting. I'm starting at A, I'm counting to 2. 1, 2. Negative 2, negative 3. Make sure you know how to do this question. You're going to see it. Here it is. I was waiting for this. Knew I'd see it. The diagram below shows a ramp connecting the ground to a loading platform 4.5 feet above the ground. That's fantastic. The ramp measures 11.75 feet from the ground to the top of the loading platform. All right, I have a picture. Determine and state the nearest degree of the angle of elevation formed by the ramp and the ground. Here's the ramp. Here's the ground. It wants this angle. It's a right triangle. There's an angle involved. So, I know I'm going to have to use Sohcahtoa. H, A, O. What's involved? H is 11.75. O is 4.5. So, sine of theta equals opposite over hypotenuse. In this example, theta is x, O is 4.5, and H is 11.75. We said earlier, there's two types of Sohcahtoa problems. I want to get x by itself. I need to get rid of sine. I do inverse sine. I'm going to type this one in for you. Inverse sine of 4.5 over 11.75. Second sine of 4.5. You know what? Let's do that even nicer. Let's get my alpha y equals enter going on here. Alpha y equals enter. 4.5 over 11.75, is it? Yep. .5, there's degree, 23 degrees. Make sure you round right. Am I frozen? Am I frozen? Yeah, I'm frozen. I'm back. So we said 23 degrees. make sure you round correctly. You cannot afford to throw away points for rounding wrong. Area of a shaded sector. My favorite song. Theta pi r squared over 360. Area of a sector. So, it's telling you the area is 12 pi. So it's 12 pi for the area of the sector. It's asking for angle AOC. That's theta. The radius is, OA is 6. That's the radius over 360. So to solve this, I'm going to have to cross multiply and solve. 360 times 12 pi is something. I'm going to leave my answer in terms of pi for now. So that's 360 times 12 is 4320 pi equals 36 pi x. Divide by 36 pi. Divide by 36 pi. X equals 120. That's the central angle. It's asking for the central angle. That's your answer. Measure of angle AOC equals 120. You're going to definitely see, I don't want to say definitely, but you're almost definitely going to see area of a sector. Make sure you know your formulas. All these questions, they always come up. Just be prepared. This is an easy one, as long as you know how to do it. It says, after a reflection over a line, triangle A prime, B prime, C prime, the image of triangle ABC, explain why they're congruent. Well, a reflection is a rigid motion. And a rigid motion, I have a song for this as well, of course. Freezer, sine, and angle measure. Producing a congruent figure. Boom. Done. A flagpole. Sweet, I get to draw. There's my flagpole. Cast a shadow, 16.6 meters long. Well, I see a shadow on the ground. I don't know where you see your shadow, but this is my shadow. Tim, the guy, stands at a distance of 12.45 meters from the base of the flagpole. So here's Tim, and he's 12.45 from the base of the flagpole. And Tim's shadow meets the end of the flagpole shadow. This is what we have here. Tim is 1.65 meters tall. Determine the height of the flagpole. Did you draw the picture correctly? Because to get in, you're not going to get very far. It's a little challenging to get this picture. It's a candy corn question. Candy corn, bases separate. Are the bases involved? Yes. So separate your triangles. Big triangle, that's the flagpole, X, 16.6. Little triangle, that's Tim. Tim is 1.65. Now, this distance here, I have to do 16.6 minus 12.45. That's 4.15. Now that I have them separated, I create my proportion. I put the corresponding pieces on top of each other. X is going to go over 1.65. I'm frozen. And we're back. I got to redo the problem. We'll kind of get caught up to where we were. We had the flagpole. We had 16.6. We had Tim. he was 1.65. His shadow, oh, he's 12.45. This is what it's asking for. The candy corn problem. I separate my triangles. I got my flagpole. That's X and 16.6. I've got my Tim. That's 1.65. And we said we had to subtract 16.6 and 12.45 to get 4.15 for this distance. Now I put my corresponding pieces on top of each other. I put my X over my 1.65. I put my 16.6 over my 4.15. Cross multiply and solve. I have 4.15x equals 1.65 times 16.6. 1.65 times 16.6 is 27.39. Divide by 4.15. X equals 6.6. Doesn't seem right. Let's take a look at what we did here. My flagpole is 16.6. Tim is 1.65. That's 16.6. Flagpole is X. Oh, no, that's right. What am I talking about? The nearest 10, 6.6. All right. I think we're on to the 4 pointers now. It tells me blah, 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 nothing important except for this. GH is congruent to IH. Well, once I have two sides are congruent in a triangle, I know the angles opposite them are congruent. It doesn't tell me that the lines are parallel. It wants me to say why the lines are parallel, but I can't assume that the lines are parallel, so I can't use the properties of parallel lines. I have to use other properties. This got a little sloppy, so I'm going to erase it and just mark this and this. It says EGB is 50. DIG is 115. I cannot use the properties of the parallel lines. I have to prove that they're parallel. So what can I do here? Well, I know that if this is 50, this is 50. Because it says explain, I'm going to have to explain that. I'm going to have to say angle AGH equals 50 degrees because vertical angles are congruent. All right, what else do I know? Well, I know that this is a linear pair here, so I know that angle, so I can do 180 minus 115, which is 65. So I can say that angle GIH equals 65. I can say because linear pairs are supplementary. And if GIH is 65, this one must be 65 as well because they're congruent. So angle IGH equals 65 because isosceles triangle has two congruent angles, And now, because I have two angles of a triangle, I can find this third angle. 65 plus 65 plus x equals 180. 130 plus x equals 180. Minus 130. X is 50. So angle GHI equals 50 because, well, I added them to equal 180 because the angles of a triangle add equal 180 degrees. Now, it wanted me to prove that, or wanted me to say, explain why they're parallel. I know my picture got a little messed up here. Ooh, look at that. At this point, the alternate interior angles are congruent. So I can say that AB is parallel to CD because alternate interior angles are congruent. The most common reason people got this question wrong is because they assumed that the lines are parallel. No, you can't assume that they're parallel. You can't tell me things because alternate interior are corresponding or whatever. You have to use the other theorems to show that the alternate interior angles are congruent. You better know how to prove this. You better know how to prove the triangles given a parallelogram. There's 6 things you can do. All you have to do is 3. Whenever you're proving triangles are congruent, you have to prove 3 things. You want to prove AED and CEB. So I don't know how much space I'm going to have here. I can state, first of all, you have to tell me that ABCD is a parallelogram. Yeah. Trying to write small, I don't know how well it's going to work out. AD is congruent to BC. Opposite sides of P-gram are congruent. I would then do diagonals bisect each other. AE is congruent to EC and DEEB. In a P-gram, diagonals bisect each other. Don't tell me they're congruent. They're not congruent. In a rectangle and a square they are, but that doesn't give you those values. That's it. I have my 3 things. I can state triangle AED is congruent to triangle CEB. FFF is congruent to FFF. Now, I didn't have to do those 3 things. There's other things I could also have done. Vertical angles are congruent. I could have done alternate interior angles are congruent. And again, alternate interior angles are congruent. You could find all 6 when you're doing this. Make sure you're able to do this proof. It then asks a follow-up question. Describe a single origin motion that maps them. Well, you could have done a rotation about point E or a point reflection in point E. either one of them sufficient. They're both the same thing. If you remember, a point reflection is a rotation. A lot of words. I don't know where I'm going to do the work for this, but I guess I'll have to find a way. A lot of words. You need to recognize this picture. I recognize this picture as hill steps. In the diagram below, the line of sight from the park ranger station P to the lifeguard chair L on the beach of the lake is perpendicular to the path going to campground C and the first aid station F. A lot of words there. It's just describing what's going on. It's telling me what each letter represents. It's pretty obvious. Park ranger station is P. Lifeguard is L. Campground is C. First aid station is F. All right. The campground is 0.25 miles from the lifeguard chair. Nothing there. It's in the picture already. The straight paths from both the campground and first aid station to the park station are perpendicular. I have that picture. This whole first thing gave me nothing. So let's get rid of it. So I have some space. Yay. I still got my health stats there. If the path from the park ranger station to the campground is 0.55 miles, I have that in the picture already. Determine and state the nearest hundredth of a mile, the distance between the park ranger station, P, and the lifeguard chair, L. This is what it's asking for. Now, even though this is a hill stats picture, all this is a right triangle. Define the missing side of a right triangle, Pythagorean theorem. 0.25 squared plus x squared equals 0.55 squared. Use a calculator. 0.25 squared is something. 0.0625 plus x squared equals 0.55 squared is 0.3025 minus 0.0625 minus 0.0625. X squared equals minus 0.0625. 0.24, square root of each. X equals to the nearest hundredth, 0.49. So, does that make sense? Sure. That looks like the number fits. I am up to here. Gerald believes the distance from the first aid station, so let's do different colors now, from the first aid station to the campground is at least 1.5 miles. Well, I don't know. I got to find it. So this whole thing is going to be X. Once I know what it is, I can determine if it's at least 1.5 miles. Well, again, this is a hill stats question. Is it hills or is it stats? Well, is there a leg involved or an altitude involved? Both of them are involved. Because what it's asking for is H, I'm going to use hills. H is X. The leg is 0.55. The leg is 0.55. If I'm using this leg, I have to use this segment, which is 0.25. 0.25x, and cross multiplying, equals 0.55 times 0.55. I'm using my calculator for that. Is 0.3025. Divide by 0.25, divide by 0.25, x equals 1.21 miles. Gerald believes that at least 1.5 miles. Is 1.21 at least 1.5? No, at least means it could be that or more. It's less. So no, Gerald, you're wrong. 1.21 is less than 1.5. Stupid Gerald. That's a 4-point question, my friends, on the Common Core Geometry Regents. It's really not too bad. The word problems will throw a lot of people off. Just take it one little piece at a time and read it very carefully. 6-pointer. I like this question. I know a lot of you guys don't like this question, and girls. I do. Got some cheap, cheesy picture they took off Wikipedia, and they got some weird diagram of it. I'm okay with it. The water tower that's pictured below is modeled by the two-dimensional figure beside it. End of sentence. Great. Don't care. Let's move on. The water tower is composed of a hemisphere. Got it. Oh, that's not a hemisphere. What am I talking about? My hemisphere. Okay. See it. Cylinder. See it. Cone. See it. Let C be the center of the hemisphere, and let D be the center of the base of the cone. Got it. Didn't tell me to do anything yet. It's just explaining what is going on. So I'm done with that. I'm going to move my picture up so I have some space to work. I'll throw my picture. If AC is 8.5, that's in the picture. BF is 25, that's in the picture. EFD is 47, that's in the picture. Determine its base the nearest cubic foot, the volume of the water tower. There's 3 shapes. So I have to find the volume of all 3 of them and add them together. So you have a reference sheet that has a bunch of the formulas. You also need to know, we did it earlier, volume is the area of the base times the height. So let's do the volume of the cone first. 1/3 pi r squared h. Problem is, I don't have the height. So I know that the radius of this circle is 8.5, which makes this 8.5, which makes this 8.5. And to find this, I can use Sohcahtoa. Because the picture's a little bit small, I'm not going to write all my little things in, but I have O and A. So it's tan of 47 equals x over 8.5. Then I get my calculator. Tan of 47, you type that in. You get 1.0724. I rounded. Equals x over 8.5. Cross multiply and solve. I get 9.115 something. I'm not going to round it yet until I'm done with the problem. So to find the volume of the cone, it's 1/3 pi. The radius is 8.5 squared times 9.115. I type that into the calculator. I'm just going to reuse the answer I have in there already. I'm not going to retype that 9 point whatever. 1/3 pi 8.5 squared. Then I'm just going to paste that 9.11. And I have 689.65. It wants it to the nearest cubic foot, so I'm going to round to the nearest 10 for now to be safe. That's the volume of the cone. Now I got to find the volume of the cylinder. I'm going to erase this Sohcahtoa over here so I have some space to work. Volume of the cylinder is on the reference sheet. It is pi r squared h. So radius is 8.5. The height of the cylinder is 25. Type that into the calculator. I'm typing pi in because it wants the answer rounded. And usually for these real life problems, you're going to want actual numbers, not things that are in terms of pi. I got 5674.5. All right, third shape. I don't know where I'm going to do all this. I'm sorry, it's not a sphere, it's a hemisphere. Well, sphere is 4/3 pi r cubed. So hemisphere is half of a sphere, so it's half of that. Volume of the hemisphere is 1/2 4/3 pi radius is 8.5. I'm frozen, of course. We're back, potentially. Am I back? I'm back, sweet. 4/3 pi r is 8.5 cubed. Type the whole thing into the calculator. 1/2 4/3 pi 8.5 cubed. I got 1286.2. So the volume of the whole tank is the cone, 689.7, plus the cylinder, 5674.5, plus the 1286.2. The volume of the whole thing is, let's find out, 689.7 plus 5674.5 plus 1286.2 is, to the nearest, 7650 cubic feet. Don't say you can't read my handwriting. I'm a little scrunched here, doing the best I can. So, let's free up some space. I'll let you look at this for another 4 seconds. Let's keep the picture for now. Because I'm not done with the problem. Not even close. Well, I don't know if I'm close enough. Now, this is what I'm up to. The water tower was constructed to hold a maximum of 400,000 pounds of water. So we're talking about weight now. If the water weighs 62.4 pounds per cubic foot, can the water tower be filled to 85% of its volume and not exceed the weight limit? Why do I gotta make it so confusing? Why have to word it like that? I don't know what to tell you. Basically, is the whole tank going to be full? No. So I don't care about its full volume. I want 85% of its volume. To find 85% of its volume, all right, volume of 85%, you're going to take 0.85 and you're going to multiply it by 7650. So 85% of the tank, I'm going to put that into the calculator, 0.85 times 7650 is 6502.5. That's how much water it could hold at 85% of its full. Now, it's asking about weight. Now, I know that weight equals weight times volume. So the weight for 1 cubic foot is 52.4 pounds. The volume, again, we're using the 85% volume, is 6502.5. So the weight of this thing is going to be, I'm just putting it in my calculator, 405756. This is how much this water tower is going to weigh, not including the actual tank. The amount of water inside is going to weigh that much if it's 85% full. So it was constructed to hold a maximum of 400,000 pounds. So is this thing going to work? No. 405,756 is more than the 400,000. I understand there's a lot of little components to the end of this question, but you got to read it carefully and just do what it says. It wants 85% of the volume, so multiply the volume by 0.85. It wants weight. You know about weight equals weight times volume. So this takes the volume multiplied by the weight. But it asks you some question with some weird words. You do the best you can. You read it. You make sense of it. And that's it. I think the math itself is pretty straightforward. But a lot of little pieces, so you're going to have to practice a problem like this if you want to get it right. I got one more question, don't I? I like this one better than 35. I actually have space to do it. In the coordinate plane, the vertices of triangle RST are R, 6, -1, S, 1, -4, T, -5, 6. So it's a triangle. You're going to take a straight edge and do this. You're not going to be lazy like me. Not be lazy, I just can't use straight edge in this thing. Or I choose not to. Great. Prove that triangle RST is a right triangle. Sweet. I know how to do that. Do you know how to do that? If you don't, make sure you do. Triangle RST is a right triangle because its sides fit into Pythagorean theorem. You have to write this out. You can't just do the math. You have to write the explanations. With the exception of trapezoid, everything is distance. To do this, I have to do 3 distances. So I'm going to do the distance of RT, the distance of RF, and the distance of ST. We did distance earlier. Let's use a different color. RT, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7. RS, 1, 2, 3, 4, 5, 1, 2, 3. ST, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 130, 34, 136. Something's not right. Oh, it's not 130. 121 plus 49 is 170. Radical 34, radical 136. So now to show that the sides fit the Pythagorean theorem, I got to see that. I have to see a squared plus b squared equals c squared. I got to see radical 136 squared plus radical 34 squared equals radical 170 squared. The square and radicals cancel. We get 136 plus 34 equals 170. 170 equals 170. Checks out. I'm not even close to being done with the problem, but I definitely just racked up some points. I'm going to erase this now so we can do the rest of the problem. Pause it, look at it. Going in 3, 2. That was smooth. All right, so I'm up to here. State the coordinates of point P such that quadrilateral RSTP is a rectangle. It wants it to be a rectangle. Well, if it's going to be a rectangle, I know approximately I'm going to end up somewhere over here. So, whatever from R to S is going to be the same thing from T to P. So from R to S is down 1, 2, 3 over 1, 2, 3, 4. This got a little messed up. It's down 3, down 1, 2, 1, 2, 3, left 1, 2, 3, 4, 5. So I'm going to do the same thing here. Down 1, 2, 3, left 1, 2, 3, 4, 5. That's not right. In order for it to be a rectangle, rectangle. It's got to be up over this direction, up in the other direction. So I'm going from S to R, so that's 1, 2, 3, 4, 5, 1, 2, 3. So it's 1, 2, 3, 4, 5, 1, 2, 3. That makes it a rectangle. Hopefully, visually, you can see that. Again, using a straight edge is going to make it a lot easier to see, because that means a straight edge does have a hard time seeing that. It says to state the coordinates, 0, 9. Now it says to prove that quadrilateral RSTP is a rectangle. Well, I know how to do that. RSTP is a rectangle because two pairs of opposite sides are congruent and diagonals are congruent. Fixed distances. Again, you're always doing distance except for trapezoids. If you're not sure how many to do 6. So I did 3 already, but I erased them. Oh well. Do them again. I need TP. I need PR. I need RS. I need ST. And now I need the diagonals, which are PS and TR. TP, 1, 2, 3, 4, 5, 1, 2, 3. PR, we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. RS, we've got 1, 2, 3, 4, 5, 1, 2, 3. We've got ST, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. PS, we've got 1. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And TR, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7. We're really earning our points here. Radical 34, radical 136, radical 34, radical 136, radical 170, radical 170. Now, you have to tell me that the opposite side, what's congruent and why. So, TP is congruent to RS. PR is congruent to RST, and PS is congruent to PR because they have the same. Again, I'm sorry, 30's a little scrunched. Not a lot of space to work. Wish I can get some multiple board action going on here. That's your 6-point question. That's your June 2015 readings exam. Watching this alone is not going to do anything for you. You need to practice these problems, practice this. If you get stuck, refer to this. But you have to be able to do the problems. Very straightforward. Most of these problems, so make sure you know how to do it. I'm done. I'm going home. I just did the trig Regents before this. I'm tired. Take a break yourself, and then continue. Hope you enjoyed the past hour and 20 minutes and 7 or so seconds.